Hi, my name is Brian Pickworth. I'm with Farmington Hills, Michigan, DPW. Today we're hoping to show you a quick and easy way to calibrate a manual drop tailgate spreader on a truck with manual valves. The goals today for this simple video of calibration a manual truck and manual valves on a typical drop tailgate spreader is to make the operator and the operations aware of how many pounds per lane mile is being applied during a snow or ice event. It makes you aware and everybody else around you how much you're actually applying. It's better for the environment to use less salt when you can, when it's safe to do so. Also, at the beginning of an event, you and your supervisor can agree on a base point what to start on during that event, and you may have to adjust the pounds up and down after that depending on how the temperatures go. Important items to check, especially with your truck, is do a thorough walk around, make sure it's safe. Really important is to check your fluids, especially the hydraulic fluid. You need to make sure your truck's warmed up with that proper level of hydraulic fluid to make sure you get a proper calibration. Also, remember to turn your PTO on if you have a electric activated PTO switch to make sure those fluids are moving through all the hydraulics. Important items you're going to need to do this process thoroughly is a good scale. We went on a co-purchase with the City of Wixom, Michigan to purchase a scale, and it's really moved the process along a lot quicker and been very efficient for us. You don't have to have a big fancy scale to do this process. You can also just use a simple bucket with a human scale, set the bucket on a human scale, or you can hang this bucket from a fish scale or some type of hunting scale to do that. It's also very important on the end of the auger shaft to either place a zip tie so you can count the revolutions once we start the process, or just a simple dab of grease in the back of a piece of white paper with an arrow on it so you can correctly count the revolutions that way. The next important step in this process is have your coworker sit in the cab of the truck and have them make sure the truck is running between 1,500 and 2,000 RPM. That way they also have the stopwatch or device to time the 30 or minute-second drop and count the revolutions of the auger. It's already in the truck with them, and you can stay in the back of the truck and count the revolutions. Just a quick reminder, when you're calibrating each truck, make sure on each sheet that you write down the equipment number and the number of the auger in case you have a different auger or a couple different augers for the certain piece of equipment. Make sure your spinner circuit is on 0. We're only concerned about the auger circuit, so make sure your spinner circuit is on 0. Make sure the operator has the truck running, warm, and for this particular piece of equipment, we're going to run it at 1,700 RPM. Go ahead, Mike, start up the truck. When he says start, I'm going to count the revolutions until he says stop. Okay, Mike, I'm ready. We're going to go all the way up to auger 5 setting. This truck maxes out hydraulic capacity after 5, so even if we did all the way to 10 on the auger setting, the revolution per minute after 5 would be the same. So we're going to go up to 5 for this next step. We're going to go 2, 3, 4, and 5. Now to test the next auger setting, which will be 2, take your piece of paper with the simple grease on it. I call it zeroing it out, up and down. Then I'll have Mike restart the truck. Make sure everything's warm still, and we'll go through the process again for 1 minute. We'll count the revolutions. So on this particular piece of equipment with a 9-inch auger at 1 minute, on auger setting 1 we got 6.5 revolutions, auger setting 2 we got 16.5, auger setting 3 we got 26.5. So you can see it goes up to a certain point, then once the hydraulics max out you should be getting the same number probably after 5, 6, 7 and so forth. Okay, the next step in this process is called the drop test of the material. You want to make sure that the operator's got the truck running 1700 RPMs, fluids are warm. It doesn't really matter what setting the auger is, 1, 2, or 3. For our intents purposes, we're going to do the drop test on 1 and count 1 revolutions. Make sure your counter is zeroed out. I'm going to have Mike start the truck and I'm going to tell him to start and stop after 1 revolution. Okay, Mike, go ahead. 1 revolution. Go. Stop. Okay, for 1 revolution of the auger, it was 22 pounds. You record that in column B on your chart, and that should be a constant number all the way down. Okay, we've got all the physical stuff done with the truck and the operation out in the garage. Now we're going to go over the calibration chart. I've already filled out the top portion of the chart. Like I mentioned earlier, you want to make sure you fill out a chart for each specific truck and auger. So I filled that out at the top. Now we're going to take, there's 3 columns, A, B, and C. A is the number of revolutions at 1 minute for each auger setting. So we did auger setting 1 through 5. I already wrote those down. Then we go to discharge per revolutions in pounds. That was 1 revolution, that was 22 pounds. And that'll stay constant throughout this whole chart, whether it's setting 1 or setting 10. The next column is column C, and that's your discharge rate, pounds per minute. So basically you take column A times column B equals column C, correct? So for control setting 1, we had 6.5 revolutions in 1 minute. Times that times 22 for the discharge rate, and then equals column C, 143 pounds per minute. Then we got about 6 or 7 other columns, starts at 5 miles an hour, goes all the way to 45 miles an hour, and you have to take the discharge rate, pounds per minimum, column C, and times that. For example, 5 miles an hour would be discharge rate, pounds per minimum, times 12.00, and that'll give you your pounds per lane mile. So I'm going to have Mike double check some of my math. So column C's 143, discharge rate, pounds per minute, times for 5 miles an hour is 12.00, should be 1,716 pounds per lane mile. If you were in setting 1, auger setting 1, at 5 miles an hour, that's how many pounds per lane mile you'd be putting down. And for example, just for comparison, that was at 5 miles an hour for auger setting 1. If we took 143, discharge rate, pounds per minute, that's column C, times 2.00 at 30 miles an hour, that'll give us
286.
So that would be 286 pounds per lane mile at auger setting 1 at 30 miles an hour. We hope this short video has helped you in calibration manual drop tailgate spreaders. There's a host of information out there on the internet. If you just Google Salt Institute of America, your local LTAP, American Public Works, etc. There's a bunch of winter committee and teams out there to help you as well. My name is Brian Pickworth, City of Farmington Hills, Michigan, DPW. For further information, contact me. My information will be on the end of the video. Thank you.